I'm Bob Vila. Welcome home again to our urban project here in the shadow of the Brooklyn Bridge. We're working inside today with our electrician, putting in all sorts of wiring in our steel studs, and most exciting, we're taking you on a tour of the Brooklyn Navy Yard, looking at one of the oldest dry docks in America. Stick around. It's good to have you home again. We're starting off today in the penthouse, and it's about the same size as all the other apartments, but it will have some special features, including ceiling height up here. That's the roof above us, so it's kind of slanted, and we've got almost all of the rough work happening here. Right now, I want to interrupt Eddie Fisher, our electrician. Hi, Eddie. How are you?
How you doing, Bob?
Good, good. You've got about 5 or 6 guys on your crew working on this building, so you're really tearing through it.
Yeah, we want to finish as soon as we can.
Yeah. I want to talk to you about New York City building codes in terms of the electrical rough. It's pretty sophisticated here, right?
Yes. Over here we use BX.
Yeah.
Armored cable.
Armored cable everywhere, right?
Everywhere.
And so everything we're looking at up here is your
armored cable.
Old-fashioned armored cable.
Yes. And the way we do it is after it comes in, we cut it. We insert a bushing inside the armored cable.
So now, what's the bushing for? That's the little red thing that's there.
So it doesn't cut into the cable. The wire doesn't cut into the cable.
Okay.
And we have a secondary ground, which we put this around the cable.
Yeah.
So in case anything happens to the ground, if there's not a good connection, the secondary ground holds it through.
Now, why is this better than just a vinyl-clad cable?
Because it lasts longer, and the vinyl-clad cable, it's easier to penetrate if you're doing work with sheetrock, with the nails or anything else that comes in. It grounds from metal to metal. So you never have a disruption of grounding wire anywhere around. Whereas in the plastic cable, you need the grounding wire, and sometimes it breaks or doesn't make a good connection.
In here, tell me what we've got going so far.
This is for the switching system, and we have the armored cable coming in, and as you notice, they have connections right inside the box.
Yeah.
So all you have to do is just cut the armor, and then you install it inside, and then you just screw it in with your screwdriver, and that locks it in so it doesn't move, so you always have a good ground.
Okay. Now, are you also wiring for cable and computer and all that?
Yes. This is for our cable TVs. Right over here. And for our telephones and computers, we have category 5.
So you'll be putting all of that through. Yeah. And what about the main riser?
The main riser is going to be coming down from downstairs. We have 100 amp, 220 coming to each panel box.
Now, do they let you use aluminum?
No aluminum. Copper only.
Copper only.
Yeah, no aluminum.
Everything is top flight.
Everything top flight, copper.
Well, you don't want to mix aluminum and copper if you can avoid it.
They don't mix. They don't mix.
Yeah. All right, so here we've got metal studs everywhere. Yeah. So how do you go about attaching your work boxes?
Here, David is going to be installing a GFI in the bathroom. So he'll be installing the box in.
So this will be a ground fault interrupter, which of course is also required
in all the bathrooms.
In any wet areas.
Yeah, in any wet area. And plus he's going to be bringing a direct line from the panel box straight to the ground fault outlet.
Direct line to each one?
Yeah, only to the ground fault.
New code,
as of the 1st of July, you require a separate line from the panel box to the ground fault outlet in the bathroom.
Why is that?
They want to keep it in the same circuit. They decided to have a direct line from the panel box straight to the ground fault outlet.
Okay, so self-tapping screws, and you got yourself your box in place. How do you cut this stuff?
David has a rotor cutter.
David, can I see that before you use it? What's it called?
A roto split.
A roto split. And the money head is right there. There's a circular blade, right?
Where you squeeze this against the cable.
Show us how you do it.
I determine how long it needs to be, then I make the cut.
And then you cut it.
You cut it, and you determine the length, and then
that's one clean cut. And then, Eddie, from the point of view of making the connection there, can you explain?
Yeah, you insert again the plastic bushing, and you put the secondary ground around the armor cable.
Yeah.
And then he's going to make a hole in the box, in the top of the box, where he's going to insert the cable inside. And then you have the screw on the other side where you just tighten up the armor cable to the box.
So it makes quick work out of it.
Quick work,
Yeah.
quick work.
All right, how many men did you say you've got working on this?
5 men.
That's the way to go.
Yes, sir.
All right, we'll get out of your hair.
Take care.
Thanks, Eddie.
Thank you.
We're going to spend a few minutes away from our building site visiting one of the most interesting attractions in the borough of Brooklyn. We could go to Coney Island or we could walk across the Brooklyn Bridge, but this is the Brooklyn Navy Yard on the other side of the water here. We're on the East River, and the history of the Navy Yard really goes back almost more than 2 centuries. Back in the late 1700s, there were a couple of private boat building facilities that existed here, and by 1801, the federal government had basically bought them and turned this into the first serious federal boat building facility. The John Adams, the nation's first frigate, was built here. Later on in the 19th century, Robert Fulton, the man who invented steamships, basically built the first ocean-going one here. It was called the Claremont. And I suppose to me the most interesting part in the life of the Brooklyn Navy Yard is during World War II, when thousands of Liberty ships were built right in this area. Today, the city of New York owns the whole Navy Yard and leases it out to a private development corporation. We're going to go across the water here and meet up with Eric Deutsch, who is the president of the Brooklyn Navy Yard Development Corporation. Eric, I know this whole facility is run basically as an industrial park now, but I want to talk about the historic aspects of it. We're looking at a dry dock here that's a couple of centuries old, right?
This is dry dock number 1. It was completed in 1850.
1850. And what events have transpired here? Who's been built here?
One of the most famous ships of the nation's history, the Monitor, was clad here. The first ironclad was completed here in dry dock number 1.
That was the famous ship in the Civil War.
Correct.
Yeah. And what about the Liberty ships in World War II? Could they have been built in a
Liberty
facility like
ships
this?
certainly could have been built in this dry dock, as well as there are 5 other dry docks here at the Brooklyn Navy Yard.
The entire thing is built out of granite blocks.
Yes, this
It
is
looks-
granite blocks and is in very good condition, and in better condition than the more recent vintage dry docks.
It looks a little bit like a Roman amphitheater, but the basic principle here is that you flood it, bring in a boat, and then pump out the water so that it's dry and you can work on it. But how do you mechanically do that?
There's a pump room in the front, and they'll let the water in and move the caisson out.
So that thing at the end that has kind of the anti-fouling paint and all the holes in it, what do you call it? A
The
caisson?
caisson.
And that gets...
And that'll be like almost the ship itself. It's just moved out. And the ship is brought in. The concrete blocks are put in correct place for the ship to sit on. And then the caisson is closed and the water is pumped out.
Fabulous. And the cranes, what vintage are they?
These are World War II vintage cranes. All the cranes and all the dry docks in the Navy Yard are World War II vintage and still working today.
Okay. Now, some of the buildings in the background here, which look like early 19th century buildings, are being used for different commercial uses, right?
Yes. Currently, that building, which is earlier 19th century, and this one, I believe, later 19th century, are being used by a set manufacturer for the manufacturer of sets for television shows.
Can we take a quick peek in there?
I believe so.
Eric, just how big is this place?
It's about 300 acres. It is about 45 buildings with 3.5 million square feet under roof.
Wow.
And about 200 businesses, 98% occupancy.
And here we've got...
Stiegelbauer Associates, the largest set manufacturer in New York City.
Really? Wow, this is one of the most complicated truss systems I've ever looked at. Probably 1870s or 80s now. What are they doing here now? TV sets?
This is television sets for Saturday Night Live. This building dates, as you said, to the late 19th century. It's had many uses and is now for set production.
Weekend update.
Weekend update.
Sure. Now, I understand there's a historic hospital on the site.
Yes, the old Naval Annex.
Let's take a look.
This is the old Naval Annex, the old Naval Hospital, and was adjacent to what was previously, before World War II, a residential and commercial area that was annexed for the war effort. And these large industrial buildings and large dry docks were built for World War II.
But they preserved this up
and
here.
preserved the old naval annex.
So you've got an amazingly large building. This dates to what year?
1834 Naval Hospital, and served patients from the Civil War to World War II.
It's interesting because the federal government in the early part of the 19th century did build some monumental buildings. I'm thinking this reminds me a little bit of the first U.S. post office in Washington, D.C. The colonnade across the front. Of course, some people would probably also be reminded of Mussolini's architecture. Now, what's the use of a structure like this?
Well, we are researching the potential future uses. We have a movie studio coming adjacent to us and hope there are opportunities for expansion.
But has this been boarded up and closed down for a long time?
The current use, I mean, the previous use was the Navy. They've been gone for about 15 years. The Navy left pretty much everything as is and basically left 15 years ago with pencils on the table and didn't do much to hold it up.
The building's just been empty for the last 15 years then?
15 years.
And unheated and unoccupied?
All the buildings on the 23 acres.
Wow. Well, there's definitely some potential here. Eric, thanks for giving us the tour.
Thank you.
George Saylor is here with us, and we're going to get started talking about insulating techniques, what best products to use. And George, I'm gonna interrupt you here, if I may, and ask you to take off some of your protective garb so we can see you.
Okay.
There he is. But it is a good idea when you're putting in any kind of insulation to wear a particle mask, gloves, long sleeve shirts, a hat, and eye protection, because there are little particles. Handsome man. See, we had him hidden in there.
Thank you.
Now, what we're doing here is we want to get an idea of what the best approach is to insulating this particular type of a building. It's a brick urban building with, an old roof situation like this. And you are putting in what looks like pretty traditional pink fiberglass, right?
Well, yes, I am, Bob, but this is specially made insulation. It's an R15. And it's still 3.5 inches thick.
Okay, I was just going to say, I thought it was only R11 if you had 3 inches.
We have R11, 3.5 inches, R13, and R15. The difference being that we put more fiberglass in the R15 than the R11, considerably more, because the insulation is using trapped air for its insulation value. The smaller the cell of trapped air and the more uniform, the more efficient it is thermally.
I didn't know that.
The R15 and 3.5 inches is a high-density product, and it's maximum thermal performance. You can see by squeezing it, it's a very dense bat.
Now, is this used more in commercial applications than in regular residential construction?
Yeah, typically what you're doing is you're trying to optimize the thermal value of the wall. In this particular case, because we're dealing with an old building and we have metal studding, metal conducts temperature.
Right.
And therefore, some temperature is going to transmit through the metal stud.
Sure.
Bob, what we're doing is we're splitting this bat so as to fit into the notch of the metal stud. And we're sliding the bat into that C channel, making sure we have a nice fit at the bottom. We have a tight fit between the two bats. And we slide it in to the smooth part of the metal stud. That way we have a good bond here.
Okay,
And in that way I have a nice tight fit, bat to bat, and I completely fill the cavity. What you want to make sure is that your facing, the insulation, is tight against the interior finish.
Yes, and you don't want to compress the material, though.
That is correct.
Let's watch as you fit this one in, because here you've got to do the same thing to fit it up against that edge of the metal stud, and you've also got to cut around a box, right?
Now what I would do is I would provide a guideline for where my cuts should be. And then using a straight edge, piece of wood is fine. You notch out for your electrical box. I'm going to split this bat.
So you'll get some of it behind the box.
Exactly.
And some of it behind the armored cable.
Any wires or plumbing in there, you want to split the bat so it goes on both sides.
That's a good tip.
Get in there. Then what I'll do is
Open it up along the edge.
open it up along the edge.
So that it fits in the back lip of the metal studs. Now, my next
Exactly.
question is just that. The metal studs, metal conducts the cold, and when you add up all the surface involved in a whole big wall like this, there's a lot of uninsulated space, even though you've gone to all this trouble. How do you address that issue?
The uninsulated space, well,
The metal surfaces.
The metal surface. One of the things that we're doing, Bob, on this particular job, because of the metal framing, is we're going with a high-density extruded polystyrene sheathing board. And this carries an R value of 5 for 1 inch thickness.
So by the time we're done here, we'll have a total of about R20.
That's what we're installing. Now, what the foam does is it provides a thermal break for the metal stud, which increases the effectiveness of the insulation in there.
So this can just be tacked onto the studs in a couple of places until
Just to
the
hold it.
wallboard comes up, and
Just
it's the
to hold it.
wallboard that will really
Right.
keep it.
With the metal stud, what you have is you're going to screw the drywall directly through the foam
Right.
into the metal stud, and that gives you that extra thermal protection.
What's the status of, fiberglass and polystyrene products like this in terms of outgassing?
What insulation manufacturers are doing is subjecting their products to third-party testing.
Independent lab
Independent
testing.
lab testing. There is one such organization, it's the Green Guard Environmental Institute.
Green Guard, yeah.
That tests different building materials from a rigorous testing standpoint in terms of off-gassing. These products here, the pink products, have the Green Guard certification.
That's great.
And so therefore, not just one or two, but all chemicals that might provide a hazard within the indoor air environment
Good.
Have been tested as low-emission products.
Good. Now, what are we doing in the roof situation? I noticed you got one bat up there. Is that a 12-inch bat?
Yeah, that's a 12-inch R38. Typically in the ceiling, we go with a low-density bat. Anytime you are insulating, you want the insulation to touch the interior finish.
Okay.
Okay, in the walls as well as the ceiling, because you don't want cold air to go between the insulation and the interior finish.
Okay.
That would then short-circuit the effectiveness of the insulation.
Great, George. And one last question. I know we've got concerns, especially in tight apartment situations, about sound attenuation.
Okay.
What do we do if you want to try to insulate, say, the bathroom cavity so that the noises of the plumbing are not heard in the bedrooms or in the living space? What's the best product to use?
Well, a fiberglass bat absorbs sound. Any sound is a vibration, and when the sound gets into that fiberglass, it's converted from sound energy to heat energy, and it absorbs it. So if you insulate interior partition walls, you reduce the level of noise within the house.
Okay.
And so that's a livability issue, the quiet enjoyment of a house.
Terrific.
As opposed to a thermal consideration.
Okay, thanks, George.
Thank you.
All right. That's a wrap for today. Come home again next time. We'll be in drywall and skylights. Till then, I'm Bob Vila. It's good to have you home again. Visit bobvila.com for everything you need to get the job done right. You'll find Home Again highlights, interactive tools for planning your next project, and helpful how-to articles for every room in your home. bobvila.com, the ultimate home site.